Hello, and welcome back to the Maths Behind Economics YouTube channel. We are still working with the exponents, and I'm still going to show you some maths-based questions where I'm using variables that are more common in mathematics than economics. But in this video, just like in the previous video, we are going to work on questions which have got multiple rules at the same time. However, in this video, we are not going to have the rules displayed, but I'm still going to explain which rule I'm using and why. I hope you're ready for some maths. So, our first example will be x to the fifth over x to the half. Right, I've noticed that there is a half power. I could rewrite that as a root, but if I do that, then I can't really do anything else. So what I'm going to do instead is remember that when I'm dividing exponents with the same bases, I keep the base and just subtract the powers. Now what I need to do is to see whether I can simplify what's in the exponent. Well, the exponent is 5 minus half, so let's use a different color on the side here and see what we can do with 5 take away half. Well, this is again a fraction subtraction, more like a whole number take away a fraction. So what we need to do first, we need to make that whole number into a fraction. Every number can be written as an over 1 if I wanted to turn it into a fraction. So I'm going to do this 5 over 1 minus 1 over 2. So I want the common denominator, which means I want both fractions to have the same denominator. I've got the denominator of 1, I've got the denominator of 2. If I multiply those two together, it's going to give me 2. 1 times 2 is 2. So 2 will be a perfectly valid denominator for both of those fractions. 1 over 2 already have got that denominator, so I'm just going to copy it over. But what about 5? 5 has got the denominator of 1, because the denominator is now double of the original, which was 1. I have to double the numerator as well, so that's going to be 10 over 2. And remember, if you simplify 10 over 2, that's going to give you back the 5. So we definitely haven't made a mistake, right? Now we can carry on and do the subtraction. 10 minus 1 over 2 is actually going to give us 9 over 2. Now we can get back to the original question and we can replace the exponent of x with 9 over 2. And now if I wanted to, I can rewrite as a root. I know that 2 is a square root, so I can write it as square root of x to the 9. And I can leave my answer like that. Sometimes again, you might want to leave the answer as a fractional power. Sometimes you want to rewrite it as a root. It really depends on what you need to do next with it. Second example, y squared divided by y to the negative 4. What's happening in here? I've again got the same bases to different powers and I'm dividing them. So I can just subtract the powers. So y squared take away negative 4. You have to be very careful here because the denominator is a negative number. You're going to have to take away that negative number. Okay, so pay attention and don't fall into the trap of this very common mistake. But what happens now if I take away a negative number? Well, that is just basically adding them together. The final answer is going to be y to the 6th. So here's a little trick. If you have a negative exponent in the denominator, that's going to turn into a positive exponent in the numerator. Third example, square root of x cubed multiplied by fifth root of x squared. Now the trouble here is that the roots are not the same. So I can't really do anything with these roots. What I need to do, I need to rewrite them as powers. So x is going to be the 3 over 2 powers and the second x is going to have the 2 over 5 power. And now I have got the same bases with different powers. All I need to do is add them together. 3 over 2 plus 2 over 5. Again, let's change color and do the calculation on the side so we make sure that we understand what's happening in the power. 3 over 2 plus 2 over 5. Again, I'm adding fractions together, so I have to make sure that the denominators are the same. 2 and 5 multiplied together gives me 10. So both of the denominators will be 10. But what happened to this fraction? Well, from get 2 to 10, I had to multiply by 5. So if I multiply the denominator by 5, I'm going to have to multiply the numerator by 5 as well. So that's going to have to give me 15. So here I again multiply by 5. Now, what happens from this fraction to this fraction? What I've done, I multiplied the denominator by 2. So I'm going to have to multiply the numerator by 2 as well. So 2 times 2 gonna give me 4. Sometimes it's also called the cross multiplication. So you may have seen it referred to it like this way. So you multiply the 3 by the 5 and you multiply the 2 by the 2 and you end up with exactly the same result. Now that they have got the same denominator of 10, you're just gonna have to add them together. 15 plus 4 makes 19. So we can replace the exponent of x with 19 over 10. And again, just like in the previous examples, if you wanted to, you can replace it with the root. So that would be the 10th root of x to the 19. And we can't really do anything with it because 19 is one of those numbers which we call prime numbers that are not a multiple of anything other than 1 in itself. So it's one of those numbers that you can't simplify further. Practice question number 4. 1 over 4th root of x to the a plus x to the a. Let's make sure the root is all over. So what's happening in here? If you look under the root, we have got x to the a plus x to the a. Well, we don't have any rules for adding the same base powers together. So we need to think about what else can we do because none of the rules apply here for this addition. Now, for a moment, ignore that we're talking about x to the a and just recognize that we have something and we add it to itself. So something plus the something again, altogether gonna make 2 times of that same thing. So under the root, I can replace x to the a plus x to the a by 2 times x to the a. Basically, that's the result for adding the same thing together twice. Okay, what's next? Well, we know that the root can be replaced with a fractional power. So let's do that. So that's 2x to the a to the 1/4. And then finally, if something is down at the bottom, that can be replaced as a negative power when we bring it up. Well, we can debate whether this version or this version is simpler. Some people will debate that the fraction with the root underneath is simpler. Some people will debate that we have a single power that's simpler. Again, as in many situations previously, it will depend on what you want to do with the answer afterwards. Right, let's make a bit more space and look at the last example for this video. X squared y squared multiplied by x to the negative 2 plus y to the negative 2. Well, again, inside the bracket, I have got x and y, both to negative second power, but x and y added together. Again, there is no rule for addition, so can't really do anything else other than multiply out the bracket. So multiply what's outside the bracket with each of the terms inside the bracket. So x squared y squared multiplied by x to the negative 2 plus x squared y squared multiplied by y to the negative 2. So what I'm going to do in the next step is switch the y squared with x to the negative 2. So the x's are next to one another. Y squared plus x squared y squared y to the negative 2. And now what I have here is I have got x and y's multiplied together with different powers. So I can use the rule of adding the powers together. So the new power of the x in the first term is going to be 2 add negative 2, y squared stays. In the second term, x squared does not change, and the y's power is going to be 2 add negative 2. 2 add negative 2 going to be 0 in both cases. So in the first term, I'm going to have x to the 0, y squared, and in the second, I'm going to have x squared, y to the 0. Now I know that any base to the 0 power is always 1, so I can replace x to the 0 by 1 and y to the 0 by 1. But I also know that anything multiplied by 1 is just itself. So 1 times y squared is going to be y squared, and x squared times 1 is going to be x squared. Now, if you want to be a proper mathematician, or some might say overly pedantic, then what you can do in the last step is switch the order of x and y and write the final result as x squared plus y squared, because mathematicians like to follow the order of the alphabet in the expressions. Well, I hope you have learned something new today, and I also hope that you start to feel the flow of these manipulations. I shall see you in the next video. Bye!